Section 2.2, we're taking a look today at something called Venn diagrams and subsets. Venn diagrams are just a way of organizing information. They're presented as early as about second grade. I've seen them in schools. You may or may not have encountered them. We're going to be using them for the most part to organize numbers, right, like numerical information. But it doesn't always work that way either. So for starters, let's actually just talk about what they look like. So a Venn diagram looks like a rectangle. The rectangle, we'll call it U, is known as the universal set. It's the box. And inside of the rectangle are going to be circles. I'm just going to draw one circle right now. We'll see some other ones with more than one circle later today. And this circle inside the box is just a set. So this is A. Did I label it? I did. This is a set in the universal set. So let me give you an example, just a verbal example. If this universal box, this universal set, the box, is everybody that lives in my house, like the people that live in my house, then that would include myself and my husband. We have 4 children that live in our house right now, okay? The whole universal set. The circle could be a smaller portion of that or a way of describing a grouping of that that's smaller. So the circle might be all the women, the females, okay? So it's just a subset or a set inside of or a collection that's smaller than the universal set. All right, so our first piece of information is to describe what a complement of a set is. So a complement for any set A within the universal set U, the complement of A, it's written A prime, is all of the elements in U that are not in A. You'll see we have some set builder notation there. This is A prime is the set of all X such that X is in the universal set, but X is not in A. There's some other notations that you should be aware of. For those of you who are taking any kind of a logic class, or if you take number theory, my education majors, you'll see another notation for A complement. A complement can also be written with a bar on the top of it. There are also other resources that will write it with a C in the upper corner like that. We're going to be using the A prime notation, but it's called the complement of A. Yes?
I'm sure you already answered this question, but so like what are the ones that, like what is what I see right now, so what you provided and what you wrote, or like is that like you putting the definition into like the terms?
Do you mean this piece right here?
Yeah, and
The part in the circle is just different notations that different resources use.
okay.
So have you had number theory, Renzi?
Not on the
Okay, so when you take it, the book in that class uses the bar on the top of it. But I have also seen books use the A with the C after it. So I just want you to recognize that this is one of those things in math that's not a universally accepted symbol. There's multiple options. The part over here is the set builder notation that describes it in a condensed form. So it's telling us that it's in the universal set. I'm going to draw a picture for it in a second, but it's not inside of the circle A. Okay? Okay, so I am going to come back to that screen, but the image that I was just telling her that I was going to draw, the picture that you're looking at is that it's all of this area out here, kind of if this were more, shaped differently, like the donut, right? It's the outer space This piece right here is a complement. Everything in the universal set, right? Everything in the box, but it's not in the circle. Okay? Now, in terms of some examples, this example is a numerical example. Let me give you a verbal description, actually, since I already mentioned it before. Remember I mentioned we could have the rectangle, right? The big rectangle be the people who live in my house, and the circle be the females who live in the house. The complement, that would be my husband and my son. My husband and my son would be that yellow piece out there because they're in my house, they're not female. Okay? So let's do a numerical example, though. So on this one, we have a universal set, and it's the numbers 1 through 10. Okay, the whole numbers 1 through 10. And they give us a set A. We'll call this A. And it's the numbers 1, 2, 3, 4, 7, 10. And they're asking us to find the complement. So remember, complement means the things that are in the universal set, that is 1 through 10, right, that are not listed in this set A. What numbers would be included in this? 5, 6, 8, 9. Okay, is everybody good with that? Okay. All right. The next one, it's not really a trick question, but you do have to think through the language that's involved to be able to answer it. It's asking for the complement of the universal set. So what does that mean? Well, literally what it's saying is I want all the elements in U that are not in the universal set U. All the elements in U that are not in the universal set U. What would they be? It'd be nothing, right? I consider everything and then I say that I can't use it. So what that means is that the complement of the universal set has nothing in it, and we learned notation for that last time. It was called the empty set. So the complement of the set that has everything is the set that has nothing. And if you think about it from that perspective, it kind of makes sense. We could do it from the other way too. I know this is not really here, but let's say that this is 2B. If you wanted the complement of the empty set, what would it be? The universal set, right? So complements in their sets and their complements are complements of each other. So if you said, I want the complement of A complement, well, it'd be A, right? It'd go backwards to set A. Okay, let's look at subsets, next. So A is a subset of B if every element of A is also an element of B. The notation for this is as follows. A, and it looks kind of like a U on its side or kind of a squished C with a line underneath it. It's read is a subset of, or we sometimes will read it is contained in. A is a subset of B. Okay, and I'd like to continue my verbal description where I had people in my house as the rectangle, right? The universal set. The circle is the female. And if I wanted a subset of the circle, I might look at the teenage girls, right? If you remember, I have a 15-year-old and a 16-year-old daughter. They would be the teenage girls, and they would be inside of a circle that would be inside the circle female and inside the rectangle people that lived in my house. Make sense? That's a subset. But what you might not have noticed until I say it is that this subset doesn't have anything to do with size. It's just a description that says that everything in it's inside of this potentially bigger thing, and my example was females. For example, if instead of teenage girls is my subset inside of the females, it just says girls under 50. That would include all of us. Okay? It's still a subset. It's not a very exciting subset. It further describes things, but it doesn't actually narrow anything down. Are you with me? A subset doesn't have to narrow anything down. It just has to be a description of things that are already in that set and don't go outside of that set. So you could be creating something that's set equality. We had a definition for set equality last time, and I mentioned last time we would have a secondary definition. This is it. This is our alternative definition. If A and B are sets, and A is a subset of B, and B is a subset of A, that's equivalent to saying that A is equal to B. Okay, so I gave a verbal example. Female in my house, and I have one that just says female under 50 in my house. Well, everything in one circle is in the other circle. Right? There is no differentiation among the members of those two circles, so those two sets would be equal sets. Now, if you wanted to have a set that really is smaller, then you have the bottom definition here, and that's proper subset. Now, the word proper in front of subset is an adjective. What it means is that you already have to have a subset to start with. Make sense? Right? If you say that's a beautiful dog, it better be a dog to start with or you're in trouble. Right? It's a dog already, right? So proper subset, it's a subset already. So the definition actually says if it's a proper subset, it has to be true that it's a subset. A is a subset of B. And it's not equal. What does it actually mean? Well, it really means it's smaller than. And if you'll notice the notation, in some ways, it kind of looks like that notation is something you've seen before. This bar right here kind of looks like the equal bar underneath a less than or equal to symbol, doesn't it? And you'll notice that it's not present over here. In other words, the sets are no longer able to be equal. So my example, teenage girls in my house, is a proper subset of the females in my house. And the notation that I was referring to here, I'll give you an example of it, would be something like x is less than or equal to 7 and x is less than 7. They're very similar groupings of numbers, right? But there is one additional item that's included in the first one that's not included in the last one, and it's the number 7. Okay, so it's a truly smaller set if you remove the equals to part underneath. Okay, so we're going to do 3 examples, and we're going to decide what goes in the blank. So in my math lab, what they will do on problems like these is they'll give you kind of a drop-down menu, or it's like a multiple choice kind of thing. And it'll say you have, in this case, they would say 4 options. You have the option of proper subset. You have the option of subset. That's the second one. The option of both, or the option of neither. Okay? So here's the way this goes. We start by asking ourselves, is it a subset? And to decide if it's a subset literally means we need to decide if the item on the left, or if the set on the left, all of the individual items in it are also in the set on the right. And we can just go down the list and ask ourselves, okay? B is on the left. Is it on the right? Yes. C is on the left. Is it on the right? Yes. D is on the left. Is it on the right? Yes. And if our answer is yes to all of those, then we could use the subset notation between them. It's a subset. It fits the definition. Secondary question to ask then is it smaller than the set on the right? And the answer here is yes. And if the answer is yes, that means we can also write this symbol here. Right? That's the proper subset symbol. It's a subset and it's smaller. So we really aren't going to write either of those things. What would go in the blank the way that this question happens to be worded? Both. Thank you. There's 4 options up here. We have this one, the word both, or the word neither. So the word we would have, and my math lab might ask it a little bit differently, but we're going to write in here both. Because I can put either symbol in there, I can put both, because both of those will fit in there. Now, it's probably worth noticing right now, I can never actually write just this symbol between something? Why not?
It has to be a subset first.
It would have to be a subset first. So every single time you have a proper subset, the very language in it is that it's already a subset. So while there look like there are 4 different options, there aren't 4 options really here. I can't write this one all by itself ever. Okay? So, moving on to the next one. We're going to go through the questions that we asked ourselves again. 9, that's the first number on the left, is 9 on the right? Yes. 1. Yes. 7. Yes. 3. Yes. 5. Yes. So that makes it a subset, like this. Is it smaller? No. So I can't use the other notation, the proper subset notation. This is as defined as it can be. There is something else that could go in this blank. It's not one of my choices. But what could go in this blank? Equals could go there. It's just not one of the options that I'm being given on the particular direction set. Okay? Equals might be a more preferable one for us to write down, but it's not a choice. Okay, last question, doing the same thing, starting at the beginning. -1. No. And if it fails, we're done. We don't have to keep testing anything. So because -1 fails, what does that mean? It's neither of those. So I write in the blank. I don't really have enough space, but I'll write neither. It's not a subset. It's not a proper subset. It's neither of those things. Okay, so far so good? Okay. So I mentioned that the subset is just a smaller grouping. The smaller grouping could be any number of things that are as many items as in the group or smaller. So example, in my house, I have 6 people in my house, so I could have all 6 of us. We would be a subset of ourselves. That's by definition one of the ones that we would be looking at. We could have a smaller group of us, 5, right? That's what happens when my husband takes all the children to school in the day. That's a smaller subgroup of them. So we could do different groupings of 5 people, right? We could have groupings of 4 people. We could have groupings of 3, 2, 1, and we have the empty set too, because everything in the empty set is also in the set. I mean, it's not real exciting. There's nothing in it, but it's a subset. So counting the number of different subsets is not really something that's super easy to do if there's multiple elements in the group. The bigger the group is, the harder it is to count all the subsets. So we're going to have a strategy for how we can figure out how many subsets there are. So if we have n elements in our set, then there are 2 to the power of n subsets. Okay, so we'll do an example real quick. The example we'll do is going to have the ladies in my house, my subset that I had before. It's n equal to 4. There are 4 women, 4 girls that live in my house. And if I wanted to know how many different groupings of those 4 people, with as few as 0 to as many as 4 people are in each group, I could take 2 to the power of 4. Notice it's a power, not a multiplication. How many is 2 to the power of 4? Do you know?
16.
It is 16. And there are 16 different, combinations, different groupings of those 4 people that I could make. One might include me and the 2 older daughters. One might include the 2 older daughters by themselves. One might include the younger daughter all by herself, right? All these different groupings. There's 16 different ways that we could put them together. But one of those ways includes everybody, right? It's the one, in the case over here, in example B or 2 or whatever it was, 4, number 4, the fourth one on here. The second one on here, but number 4. Number 4, that sort of ends up feeling like you're almost cheating. It's exactly the same. Like it's a subset, but only because the definition feels funny. You know what I'm saying? Right? It's the group of everything. So if we booted that one out, we would have all the proper subsets. Well, booting that one out simply means removing one of the 16. So if I take away the one that's got everything, then I'd have the number of proper subsets. So the number of proper subsets for my n equal to 4 would be 2 to the 4 minus 1. 16 minus 1, or 15. This is a really good example of a place where partial credit sometimes happens on quizzes. Let's say you counted the number wrong for like part A, right? The number of subsets, and you thought, oh, I got that there were 64 subsets. Well, if you know that you just need to remove one and it's 63, then you're going to miss both questions because you got the first one wrong. Well, that's not really the intent behind the question, right? The question is whether or not they're two different questions. The second one is, do you know that you're just supposed to take one away? So you might actually end up getting it all counted wrong, but I go back in and I see that you have counted the first one wrong, got the first one wrong, but the second one was right according to what you did on the part A, and then I would give you credit for the second one, so you get half a point instead of getting 0 points, for a 1 point question. So just an FYI, that's the kind of thing that happens sometimes in my math lab where I see partial credit options in this section. Okay, you ready to do an example? All right. We have set A given to us. Set A is the letters A, B, C, D, E. And we're asked to find the number of subsets and the number of proper subsets. And this all hinges on the number of elements. So if you remember last time, this notation, N and then the A in parentheses, means number of items. We had a fancy word for it. It was called cardinality. What are the number of items in set A? 5. There are 5 here. So on part A of this question, when I'm finding the number of subsets, what will I do? Right, I'll do 2 to the 5th power. And what is 2 to the 5th? 32. If you don't know how to get the power buttons, this might be small enough that you just know it, but there might be a big enough number that you don't. If you don't know how to get power buttons on your calculator, see me after class and we'll figure out where yours is. There's 2 or 3 different ways that calculator is going to show up in that notation. So, and then what would I do for part B, the number of proper subsets? I'd subtract 1. So I'd have 31. Okay, B is a little bit less direct anyway. It's given in set builder notation. It says X is an odd integer between -9 and 4. Okay, what does odd mean?
Less than 0.
Nope, that would be negative.
Oh.
Odd.
The opposite of even.
The opposite of even, right? It's not even. Even means it's
Divided by 4.
It's able to be divided by 2. Yeah, even means it's divisible by 2. So odd numbers are things that are not divisible evenly by 2. That's really what it means. So all the numbers that are not divisible by 2. And intuitively, I think you know what they are, but I'm just asking if you can think through that. What does between mean? That might be a harder question. Less than or greater than? Between. Do we get to include the -9 and the 4? No, -9 does not get included because of the word between. Why is 4 going to get excluded, though, honestly? It's even. Okay, good. All right, so it might be helpful to start out with by just listing the numbers that this includes. All right, so it's not going to include -9. What will it include? Okay, is everybody good with that? All right. And if we call this set B, as they have already, what are the number of items in this set? There are 6. Okay, so first, good? Because you got to count the number of things before you can start to do anything else. And then now we're going to find the number of subsets. How do I do that? 2 to the 6th, which is 64. Very good. And what will I do for proper subsets? Yeah, I'll take that same value, subtract 1, and I'll get 63.